So just briefly, a little bit about myself, just like everyone else here. I live in Brownsburg, Indiana, just west of Indy. I only have a very small plot of land, but I do try to do a lot of gardening in my backyard. I work with my two daughters to try to grow food, but a lot like what Bree was saying, you have to come to the conclusion really quickly that you can't grow it all yourself, and trying to find other strategic ways to have access to food that is grown and raised the way that really follows these soil health principles. That's what we're really interested in. And so I work with NRCS here in Indy, and I'm the soil health specialist. So this has been a passion of mine probably since the first time I saw Jay Fuhrer in North Dakota talk about soil health at the Minokan farm, and have just been on fire since then. So we're going to talk about soil health basics today. My job is to lay the groundwork and get so that everyone else can kind of go from here and get you all full of information and thoughts and ideas about what to do on your own operation. So the first thing that I really want to start with today is just to really think about what we mean when we talk about soil health, just so that we're all on that same page, right? So that when we start to talk about, well, I want healthier soil, or I'm looking for soil health, or I'm passionate about soil health, or I want to know more about soil health, right? It's such an interesting noun that we talk about, soil health. And so let's just think about the fact that when we're talking about building healthy soil, or we're talking about soil health, we're talking about that capacity of our soil to function as a living, breathing ecosystem that sustains plants, animals, and humans. And so that definition is really important, and there's so many key words in there. And the key words that I want you to really like kind of almost like meditate on or really think about as we move forward are the words function. That the things that I'm going to talk about today in these soil health systems, this is what our soil was designed to do or created to do, or however you want to think about that when a soil is functioning properly, these things just kind of work in a way that we come to realize that soil doesn't really need us to be successful. It can function on its own. And so we want to talk about this vital living ecosystem as well. Many of the people on this call or in different circles that we hang around with, there's a lot of talk about ecosystems above ground and things like that. But you need to be fully aware that there's a whole living ecosystem below ground as well, and that ecosystem is thriving, and that when it is functioning well and it's living and it has health, it is able to sustain. And let's just maybe pause a second and say, maybe not just sustain, but even regenerate plants, animals, and humans. All of the things that grow in and or benefit from soil are able to be sustained and or regenerated in our healthy soil ecosystems. So let's take a step back and then just talk about the real basics of soil, right? So when we think about what is soil, so often the first thing that everyone thinks about is sand, silt, or clay, right? I have clayey soil, I have sandy soil, or I got that silty soil, whatever it is like that. But a lot of people think about soil just in terms of the mineral component of their soil. And when we have our healthy functioning ecosystems, right, our healthy functioning soil ecosystems, that mineral component of our soil is less than 50% of what the actual composition of our soil is. That other 50%, or the other majority of that soil composition, is nothing. And I say that with a lot of emphasis that, right, the other half of our soil that's so essential is nothing, is space. And that space is so important because it allows that soil to have space for air and water to freely flow into that soil. Because most of the organisms that live in the soil are aerobic, so they need to breathe. And a lot of the plants that live in our soil, those roots, they are aerobic as well, so they need to breathe. So there needs to be the ability for soil to exchange air and water into it. So that pore space is an essential component of healthy soil infrastructure. And that last little piece of that pie there is our organic material. And that ranges from recently dead stuff to really, really, really dead stuff, like dinosaur dead, right? So, but those are all essential components of our soil. And if we take that organic proportion that we saw there, typically, you know, people will assume somewhere in that 3 to 5% range is what the organic material portion of our soil is. If we take that 5% and we turn that into another pie chart, you can kind of see just the stages of decomposition of organic materials that there are in our soil. There's everything from, you know, stabilized and decomposing organic matter, our fresh residues. So that would be residues that were recently harvested, you know, last fall, or kind of as you mow your lawn, think about that stuff as fresh residues, right? But then the other thing that's really cool to think about in here is that organic matter is not just these things that are dead, but also those living organisms that live and thrive and make soil their home. And those living organisms is a really small fraction of that 5% organic matter. But if we take a closer look at the role that they play, or the number of organisms that are in that soil, it's just mind-blowing. And what we come to realize is, if we go back to that soil health definition, right? The capacity of soil to function as a living ecosystem. One of the things that we want to circle around is just thinking about the fact that if we want to learn more about soil health, or if we want to think about building healthy soil on our farms or our lands or our backyards or our gardens, it really comes back to thinking about that living component. That soil health really focuses on life, and that life has to do with the organisms that live in our soil. And this is a great little chart that kind of looks at the number of the billions of bacteria and fungi and other things that we find within our soil. And the equivalent that they have determined here on this graph is, in about 2.5 acres, there's about 20 cows worth of weight of living organisms. That's not the dead stuff. That's not the residues. That's not the very, very dead dinosaur stuff. And that's about 8 cows in an acre, let's just say. That is the living bacteria and fungi and nematodes and millipedes and beetles and worms and spiders and lice and all of these things that live in that soil and make it their home. So imagine that, the weight of 8 cows worth in an acre of soil. More simply put, that talks about, in a tablespoon of soil, there's over 1 million bacteria and fungi, and 1 million fungi, and hundreds of thousands of other types of organisms, and that is just in a teaspoon. So again, just really wanting to bring that back and into light, that when we start to think about soil health, it's about thinking about life and living organisms and how we can create that ecosystem for everything to thrive, including the plants that we grow. So let's think about some of those properties that I was talking about, right? Or we think about the different components or things that make up soil. We talked about, sand, silt, and clays, and organic matter, and different things like that. And as we start to talk about these things, we start to break things down into different types of properties. There's physical soil properties, there's chemical soil properties, and there's biological soil properties. And going to college 20 years ago, and many of you who have been around with farming and growing food for a long time, you know that we've focused for years and years and years on physical soil properties and on chemical properties, right? We do a soil test. Here's what we need to apply to our soil, and that's looking at those chemical properties of what's available for nutrients in the soil and what do we need to supply, and thinking about physical soil properties, whether our soil has stable aggregates or what that structure is, or different things like that, right? But the biological soil properties, that's kind of the new realm. And by new, I mean probably in the last 10 to 20 years, things have really blown up in starting to understand biological soil properties. And especially in the last probably 5 to 7 years, that more and more people are really interested in trying to understand these biological soil properties, not just organic matter, but the role that plant roots play in feeding organisms. And again, that biological activity, and then the fact that that the number of soil organisms that have been identified in the soil is less in the soil than there is in the ocean or any other place on the world. And so again, this is like the next new frontier for thinking about a life and understanding it more fully. And then, so the thing that we're really starting to learn now is that those properties, like I talked about, are they all equal? Because I have them in that great Venn diagram there, and they're all nice little same size circles. But one of the things that we've learned is that those biological soil properties, they are estimated that they control or manage up to 90% of the function that occurs in the soil. So that means that the biological soil properties, they're really the gatekeepers here. And so our job is, when we think about soil health, is to try to manage for soil life, manage for them so that they can thrive, and all of the other functions that we want to see, that they can occur. So when I talk about functions, what is it that I'm talking about? And so here's just kind of a nice little picture thinking about what a soil's function is. And we'll delve into these when I do the demos in about 5 minutes here. But when I talk about a soil's function, that means the ability for a soil to infiltrate, store, and filter water. When a raindrop lands on the ground, we want it to soak in where it lands. And then we want that soil to be able to hold it in its pore spaces until it releases it back to the growing plant. Or if that soil, that capacity, it can filter that water through the soil and release that water to a lake, river, or stream. So that's, again, an important function of our soil. And that other picture on the top right, it's talking about cycling nutrients. And that's a hard picture to tell what that is, but that's actually a corn root ball that was from last year. And when we dug it up, there was actually a cover crop that was growing through that root ball and out the bottom, and you can see there's some nodules there on that picture. And those nodules, again, so again, that plant is taking nutrients that are being released from that corn crop as it decomposes, pulling those nutrients into that plant, into that new growing plant. Therefore, those nutrients are cycling from one plant to the next. And bacteria and fungi play a really key role in aiding in decomposition and cycling of nutrients. When we think about physical stability, that picture on that bottom left, when we think about what going on in our gardens and planting our crops, we need to have that soil be a physically stable platform on which to farm. So if you are using tractors, right, you want to be able to drive across that field and not sink into that field. If we're in our backyard gardens, when we put that plant into our soil, we want that soil to hold that plant up and not have that plant fall over. So again, thinking about that as an actual foundation for that plant to grow in. So that soil has to be stable. If it's not stable, you'll see some pictures of that in a second. But again, think about that as a physically stable platform. So those soil particles actually hold together and hold to each other. And then that last one on the bottom right here, a habitat for soil life. And I mentioned that last, but if you've kind of gotten the gist of the conversation here, is that really that kind of is one of the most important things that we want to think about, is that habitat for soil life. As we increase the number of organisms living and thriving in our soil, they do a lot of these other jobs, but that habitat for soil life kind of comes back to us and how we manage that landscape. Because if we can manage for that soil life, then that soil life can start to help with those other functions. So when we don't have those soil functions, or we lose those functions, we start to see characteristic things that occur on the landscape. When it rains, our soil is unable to infiltrate or store water, so we're left with ponded conditions, which unfortunately can lead to erosion and runoff. Or we have these corn residues in the top right-hand side here, are different types of residues, and this is kind of a large field type condition. But if that water isn't soaking in and it's running across the landscape, it's going to carry the organic material and leftover residues right off the field and put them in a road ditch. And then they're no longer a resource that can be broken down and nutrients released to the next growing crop. They become a waste product that someone scoops up out of the road ditch and throws away. And think about the loss of those nutrients from those residues. And then if we don't have physical stability on our landscape, like that picture on the bottom left, then we have erosion problems. And this is just a great picture of a wind-blown field that I remember seeing one time, where the soil particles were worked loose, and then the wind came up, and that soil just blows away. And if it's not blowing away, it might wash away with rain events or other things like that. And then lastly, when we have that loss of function, we don't have that habitat for soil life. So that soil washes into the road ditch, and that surface of that field left in that picture there becomes a crusted surface. And when we have that crusted soil surface, we can no longer successfully exchange air and water into that soil. So our organisms are fighting to get the oxygen that they need. And then every time it rains, that water's fighting to get in. And so we've kind of destroyed that habitat. So we see these characteristic examples of when our soil starts to lose function. All right, so when we think about what types of principles that we can use, or when we talk about soil health and trying to implement soil health on land, in conversations with farmers and professionals across the country, there was a few things that kept kind of floating to the surface as things that those farmers really focus on. And it's identified here in these soil health principles. And these principles, like in the middle of the circle, it talks about 4 urban soil health principles. And the reason why it says urban there is because Ellie and I had been working on trying to make this circle have like more viewpoints from like an urban perspective. Because so often a lot of my presentations are to farmers with working in commodity crops and other venues like that. And like Bree said at the beginning of the event, these learning circles are to reach out to people that are maybe owning that land, or to, in this perspective, people that are working in small farms or urban type areas, community gardens and the like. And so I wanted to really get some perspective and get some pictures in here that focused on the types of situations that you might have on your farm. And so these principles that we keep coming back to when we look at our soil health management systems, it includes maximizing continuous living roots. And so we want to have those plant roots growing in the soil for as long as the year as possible. We want to maximize our soil cover. So again, protecting that soil surface. We want to maximize biodiversity. And then there's one where we want to do one less, and that's disturbance. We want to try to minimize disturbance as much as possible. And so when we talk about minimizing disturbance, that's things such as rototilling or other types of tillage activities that whenever you're stirring that soil, you're breaking it apart, and then you're making it susceptible to erosion, raindrop impact, or other things like that. So if we can minimize that physical disturbance, that soil can hold together better. Then when we maximize cover, I like to think about that cover like skin, or like clothing on over your skin. So that soil cover, those residues or other things like that, they're extremely important to protect that soil surface, because the solarizing rays of the sun can actually kill biology at the surface of the soil and dry our soil out and other things like that. Raindrops can impact the soil surface at up to 20 miles an hour when we have a driving rain. And if we have that soil surface protected with cover, it's just like wearing a raincoat over your skin when you're out in a rain event, or again, clothing when you're out in the burning hot sun. Thinking about protecting that soil surface, just like we would protect our skin. And then maximizing continuous living roots. The reason why we like to do that, or why that's so essential to this system, is because plant roots are the key to feeding microorganisms. Photosynthesis is where this all starts. Because when we have photosynthesis, that process creates carbon, and some of that carbon, that glucose that comes from that process of photosynthesis, is actually pumped out of our plant roots and into the soil to feed the microbes that live in the soil. And then lastly, that biodiversity option. There's so many important reasons why we want to talk about biodiversity, but a lot of it has to do with the fact that each plant that grows in our soil exudes different types of carbons into the soil. So we're feeding a multitude of different organisms. And by having different plants out there, we can strategically manage pest cycles or other things like that as well. So these principles, when you start to think about trying to improve or trying to promote soil health on your farm, come back to these principles and think about how you can do one, two, or all of these principles as you're stepping into your soil health system. But just remember, you don't have to jump in feet first. It's always important to just try to figure out what your goal and your strategy is, and then slowly step into it. But I always come back and ask myself a question if I want to do something in my garden. Am I minimizing disturbance, or what soil health principle is this helping to support? And then that kind of helps me make decisions as I'm moving forward. All right, so I'm gonna move on in just a second to our demos. So just as we talk about those principles, remember that minimizing disturbance and maximizing cover are focused on protecting soil aggregates and habitat. And that maximizing living roots and maximizing biodiversity are all about feeding our soil biology and improving the resilience in soil organic matter. So protecting and feeding, that's what those principles focus on doing. So I'm going to stop sharing for just a second. Well, a second, haha. And I'm going to turn this camera off, and I'm going to turn on my other video camera. And then we will work on these demos here. Let's see here. All right. I'm going to, Ellie, let me know when I'm pinned, and we will go from there. All right.
All right, you should be good.
It looks like we're pinned. All right. Okay, so before you here, I have these slake tubes, and there are these little tubes here, and inside of these tubes, I have a little basket. And so we're going to put some soil in here in just a minute. And if you notice, I have these titles above them. One of them, the one on the left, talks about a typical cropping system with tillage and low diversity. So that when I put that on the top of this display in the back, I didn't want to use the word conventional, and that's because sometimes conventional makes me cringe, because then when you say, well, that's the convention, that's how we always do it, that's the norm. I don't want, the reason why I changed that to typical is because typical kind of indicates that's what we see out here, but I took off the word conventional because I'm trying to promote the fact that I don't want a tillage system with low diversity and no cover crops. I don't want that to be the convention. I want our soil health system here, this one on the right, I want that to be conventional someday. So I'm really trying to focus on using that phrasing to critically get people to think about, we shouldn't just expect or assume or be okay with a cropping system where we lose soil function. That shouldn't be okay, and that shouldn't be the convention. And so that's why I just kind of called it typical, because that's what I usually see in parts of Indiana or parts of the country where I've traveled and worked. So when we do this slake demonstration, we're going to have two different soils. I'm going to reach through here just a second. Sometimes, when you have these demonstrations like this, you got to kind of have a reach in front of the camera. So these soils right here that you can see in this picture, these soils are mapped as the same soil type. But even from this picture here, you can kind of see that they look a little bit different in color. And that is because of how they're managed. This soil here, I'm going to just kind of hold it right here. Hopefully it focuses good. This soil comes from a soil health cropping system that uses diverse crop rotations and cover crops every year after harvest, low disturbance cropping. So the only soil disturbing activities that occurs out there is when that farmer is actually planting the crops and or planting the cover crops with a planter or a drill. So hopefully you can see some of the things in here There's a little bit of what I like to call topography in here. There's a lot of dips and different things like that. You actually can see some earthworm channels, some small plant roots that are hanging out in there. And so that's this soil. And this same mapped soil type from the field right next door, this comes from a really high disturbance tillage system. And so there is no cover crops that is employed in this farm. And it's a pretty low diversity cropping system. Typically corn on corn, sometimes corn and soybeans, but not a lot of diversity out there. And one of the things you can notice is that soil is maybe a little bit grayer. There's not very many pore spaces in there, and it just doesn't quite have the same look as that other soil does, or that other aggregate does. And so what we're going to do is we're actually going to put these in the water, and we're going to watch what happens. All right, let's see here. So right away, there's two things that you see. You see lots of air bubbles bubbling up to the surface on both of these, right? You can see those air bubbles kind of escaping out as that water's trying to get into those aggregates. But the other thing that I hope you probably notice is that soil on the under the in the tillage system, you see all of those soil particles starting to shed off of that clod and break into solution and into that column of water, and that aggregate is falling apart. So what's happening here on this soil is, again, when we talk about the composition of a healthy functioning soil, 50% of that soil is pore spaces, right? But if we're in a heavy tillage system, every time we go through and we break up that soil and we stir it on up, we actually break those natural pore channels up, those earthworm channels, those plant root channels, all of those things that in a no-till system are maintained. In a tillage system, they get destroyed every year, and every year that soil has to start over with rebuilding those pore spaces and allowing that area to be open. And so again, year after year after year of disturbance, and all of a sudden we don't have 50% of nothing anymore. There's no 50% pore space for air and water. It may be 40%, it may be 30%, and they aren't continuous. And so what's happening to this soil over here is that as that water's trying to get in, it can't, because there's no pore spaces, and there's no easy way for it to soak into that aggregate. And there is actually air in this aggregate, but it's trapped. And so the pressure of that water pushing on that aggregate, and that air will start to explode out of that soil. And when that happens, those soil particles actually fall apart, and that's when they come into solution. So that soil is actually falling apart before our very eyes as it's sitting here. On the other side here, this soil here, we'll notice that soil might have a few chunks coming down, right? But you notice how they just kind of float to the bottom. They don't really hang in suspension like the other one is. And that's because those soil particles, again, we have pore spaces and channels in there. So as I stuck that aggregate in the water, that water was able to push in, and it just really easily pushed that air right out, and that water and that air just escaped, and that water went in. And so it's almost kind of creating an equilibrium. But we do have some of those chunks falling down. But again, like I said, when they kind of fall off, they kind of just sink right down to the bottom. And why is it happening that way? It has a lot to do with this being a home, right? A living ecosystem, a home for soil life. When we have those organisms, that bacteria and fungi and other things that live in our soil, when they want to have a stable home. And to do that, organisms like mycorrhizal fungi and different types of bacteria, they produce products called glomalin and glycoproteins, and they use these chemicals to actually stabilize the soils. And they do this by kind of coating these soil particles with these glycoproteins and other things like that. And so as they coat these soil particles with those chemicals, it helps those particles hold together when it's in the water or when that soil is waterlogged. So they're actually building their home with those with things that they produce from their body. And so what happens is when we stir that soil, like we have here on this soil over here, as those glues that were holding those soil particles together are broken down, and they actually become food for other microbes, because those glycoproteins and other things like that, that is a food source for microbes. And so just really thinking about how when we have a healthy soil, we have a home for soil life. And this aggregate right here on this healthy soil is a great example of that, right? Because as I'm sitting here, I take this out and it's held its shape. There's water dripping out of it now, again, as the air is going back into that aggregate. And that aggregate is still holding together because of the role that the soil organisms play in helping to keep that in that aggregate to be water stable. This one over here, what we've seen is that we've lost most of that aggregate, right? It wasn't stable. It didn't have a lot of pore spaces to allow that water to flow in and that air to push out. And it didn't have a lot of those glues to help hold that soil together. And so we're left with the soil that when we put it in the water, it falls apart. And not only is that a problem for soil, but look at what a problem it is for our water and our water quality. Every spring, I don't care what state you live in, but every spring we see things like our lakes, rivers, and streams turning to chocolate milk, and things like that. And that has to do with our soil particles and our soils getting washed away. And imagine how we might see less of that in a system where more soil allows that water to soak in and not run off, where that soil is able to remain stable, even during rainfall events. All right, so does anybody have any questions about this, our slake demonstration and kind of what you're seeing here? I would be more than willing to take this soil out of here and break it open if you want to look at it. And while you're asking your questions, I'm going to get ready and geared up for the next soil health demonstration. So just ask away. And if you don't have any questions, that's fine as well. That's okay. You're not expected to have any questions. I just want to make sure that we have time available for people to ask any questions, think about what we just showed there, and just really delve into that science a little bit more. I am still there, right? It's working? I'm still there?
You're still here.
Okay, good.
We don't have any questions, but Karen said it was a great visual.
Okay, good. You guys make me nervous. You're too quiet. I'm expecting a lot more questions than that. All right. So our next demonstration that we have here is, again, looking a little bit more at the ability of a soil to infiltrate water. So we have these, let's see here. Oh yeah, we can see the trays pretty good. I'm going to tilt it down just a little bit. There we go. So again, these trays here, I just picked up those aggregates that I had earlier. I just picked them up right from here. And these soils, I harvested those soils from a field and dried them out. And when I had to dig them up, that's, I had to kind of, this soil here that's in this no-till system, I did have to break it up, right? Because I couldn't shovel it up and have it maintain exactly what it looked like in the field, because by shoveling it out, I was disturbing that. But so I now have this soil, and you can kind of notice that their textures, as they sit here, they look different as they dried, right? This soil is a lot more kind of powdery looking, whereas this soil, as it's dried and kind of breaks up, there's a lot more aggregates, and they kind of get smaller and smaller and smaller, but they don't ever really turn into that straight powder, which I call it powder, but really what that is that's our aggregates actually breaking down into their individual components of sand, silt, and clay, right? So that's sand, silt, and clay. This is an aggregate. And I call it an aggregate, but an aggregate essentially is a conglomeration of sand, silt, and clay, and they're kind of held together by that fungal hyphae, those biological glues, and then there's, again, life in those areas, plant roots, microorganisms, pore spaces, and all of those things reside in an aggregate. And what's really neat about an aggregate is you get really small aggregates, and they would be called microaggregates. And these probably aren't microaggregates because microaggregates are really, really small. But microaggregates are then held together by larger pieces of fungi, say saprophytic fungi might wrap around a whole bunch of microaggregates. And then a microaggregate, when you get a bunch of microaggregates held together, you're going to get a little bit of a larger aggregate, right? So inside this aggregate is a whole bunch of microaggregates. And then that aggregate's going to get bigger and held together by more and more pieces. And so here's a larger aggregate, right? So if I break this up, that's just a bunch of aggregates, right? But at some point in time, they were held together. And then you have even bigger aggregates, right? So again, I just want you to think about the fact that aggregate formation and aggregates in our soil are kind of what we really want to look at and think about when we talk about having stable soil and the ability to infiltrate water. It all has to do with those aggregates that we have in the soil, and it working from small all the way up to big sizes. So we're going to just take these aggregates that I have here, and we're going to put them into this container here. So there's these holes on the bottom of this container, and I'm just going to use this nice little scooper here, and I'm going to scoop this soil up. Now we're going to put it into the container. I try to scoop the big ones out of the way, just to try to get the more, I guess, maybe regular size and not the gigantic size aggregates, right? Get them all in that container. There we go. So we got a nice looking container here of aggregates. We're going to do that on the other side as well. So again, this same container over here. And we're going to scoop this up. Now, I'm not sure if you noticed when I did that, but the cloud of dust that's rising up inside of this container. Remember what I talked about with physically stable soil, or soil, thinking about how wind erosion becomes such a problem when we have this loose soil. So this soil, again, is probably more used to being broken up, and because it's regularly worked. So I've filled this container. They're about the same depth and fullness. And we're going to move these trays out of the way, and then we're going to pour some water over top of them. All right. So the next thing we're going to do here is I'm going to pour some water over top of these, and as I'm looking around, I'm taking just a moment here to grab my strainers just to put on the top of them. They're not the greatest. They don't really break out the flow of water that much, but it does kind of allow that water to kind of dissipate throughout the whole container. And we're going to pour some water on them and see what happens. Remember, I just dumped some soil in here. I really didn't do anything very special to it, right? But one of the things that you can notice again is, remember how I was talking about those aggregates, small aggregates and larger aggregates? I dumped those aggregates in here. There was enough pore spaces throughout that whole entire container. I just dumped 12 ounces of water on this small little container. and that water just ran right through down into to the collection unit in the bottom. That's certainly not what happened over here on the left with our typical conventional system, right? Oh, I didn't want to say that. Our typical system, right, where we're looking at high disturbance. And so what happened here is that soil, when that water hit the surface of that soil, it actually started to seal up. Those soil particles plugged up, and the water is slowly starting to kind of soak through the soil, but it's not occurring very fast, is it? And think about this in our fields and our gardens and things like that. When we want that water to soak into it, but that surface is now sealed up and it can't let that water to soak in very well. And so then we just have to wait, just like a mud puddle. Think about how long it takes for water in a mud puddle to soak in. And so then that's kind of what's happening here is that water is slowly soaking in, but it's not happening very easily through those aggregates or those other pore spaces or channels. It's having to basically create pressure, almost like head pressure. That water is having to push down through that soil. And then there's not a lot of pore channels or spaces for that water to soak into that soil.
Puppy, stop.
So, oh, Brianne, I'm so glad I'm not the only one that's having puppy issues, because there was a puppy in my room too, and it was distracting me.
Oh my gosh, sorry, I'm not on mute.
So anyway, so think about that, and the ability, that function that we want to really talk about is that the ability of that soil to infiltrate water and then to store that water, right? Because in this picture here, it might have soaked down into this container here, but this kind of is like our hypothetical storage in the soil profile. Whereas on this other side over here, we don't really have anything in storage, and we have a lot of stuff still sitting on the surface of this soil trying to soak in. And we have this nice container here. That's really what the world looks like, right? And that water would have run over our garden or our field a long time ago. It would have gone into the rain gutter, down the drain, or in large field situations, a farmer probably would have put an intake here to get rid of this water, or we would be on a hillside, right? And this would have run off how long ago? So again, creating other resource concerns or problems out there. And so it is so essential when we think about our management and how we manage that soil, how that promotes or demotes soil function and soil health. So again, really thinking about what soil health means and how we can kind of use these demonstrations to then relate it to those principles, right? Because here we have high disturbance and we're seeing infiltration. Here we had low disturbance and those aggregates were maintained, and we were allowed to, we saw that infiltration was maximized. All right. I'm going to move on to our last demo, and then we should have time for discussion. We got about 15 minutes left here. Does anybody have any questions as I'm switching to the last demo? This last demo hopefully is going to kind of tie everything together in a larger picture kind of perspective, right? We first kind of started at that aggregate, right? Those clods that I was telling you about. And then we moved up and we talked about like a handful of aggregates, right? We scooped them up and we put them in those infiltration containers. And so how do those aggregates hold together? Not just on that one clod scale in the tube, but like how do they all hold together? Do they allow water through them or not? That's what we looked at just now. And now we're going to take this and we're going to kind of tie the last piece of this puzzle together and think about this from a watershed scale with these larger infiltration containers. Pardon my reach as I kind of stand in front of the camera here. It's not seamless. I'd like to be able to stand right behind my camera, but then there would be a shadow and it never always works the way I would like it. But I think that we're getting some pretty good graphics today. So on these containers here, this container, I'm going to just turn it to the side here. This metal thing is called a cutter. And we are actually able to use this cutter push it down into the soil profile and pop that out of the soil. So we essentially have kind of an undisturbed soil profile in here, about 4 inches deep, 8 inches long, kind of brick like that. And so again, we have two different managements here. This soil comes from a no-till cropping system. This farmer's been using a lot of diverse crop rotations for many years now. And so I think when I collected this soil, there was, I don't know, 8 or 10 different types of cover crops that were growing on this field. And I was able to get a little bit of that residue showing when I collected that soil. On the other side here is our soil that comes from more of a tillage system. And let's just imagine that this is what it looks like. This is what these soils look like right before it started raining. I don't know where you are in Indiana, but it's raining in Brownsburg today. And before that, it was kind of dry, you know. And so it had rained a little bit a few days ago or a week or so ago. And then the sun had kind of baked that soil dry. So it was starting to look like something like this on the surface. Or here, you know, it was looking like some of these residues here on the surface. But now it's going to rain again. And what's going to happen on these soils when it rains again, on top of these different types of management systems? And so that's what we're going to kind of demonstrate now here when we rain on these soils again. So you can see those containers up on the top. Again, there's holes in them. All right, I'm going to turn the camera down just a little bit. I mean, so we saw some pretty graphic differences here, right? We have, here's a soil, it rained on it, and maybe a little bit of water soaked into that surface, much like that container on the left that we just saw. And then the rest of it ran off into this cup in the front. And actually, we're left with a pretty serious ponded situation here. The soil can't infiltrate the water very well. And when I set this thing up, I set it at a slightly flat angle because my goal here is to show that, you know, we can see erosion and runoff even when you don't have hilly ground. And that's a really important thing to think about when you come from flat lands, especially in the northern part of Indiana, where it's relatively flat and you don't think you have erosion, but you do have erosion and you have soil loss. It's just that it's not as visible as a gully running down your hill. And so here on this one, we had a lot of runoff right there. Whereas a comparison on this soil here in our soil health cropping system, we didn't have any runoff at all. So where did all that water go, right? Into our living, breathing ecosystem, right? To help sustain plants, animals, and humans. So let's kind of look at what these systems look like a little bit more. So here's our healthy soil. I'm going to just kind of tip it up like that so you can see it rained on the surface of that whole thing. And what does it look like on the bottom? Oh, didn't get quite as much rain over the whole bottom as I would like. This one's been dry for a while, this field has been. So, but what you can see is that probably 50% or more of this brick, the water infiltrated in. There was some pretty great earthworm holes right there. There's an earthworm hole right there. So again, that's a macro pore, which would be really essential for heavy rainfall events. And so we had about infiltration over 50% of this surface, which is pretty good. I would have liked a little bit better, but that also is okay because we're seeing that infiltration, and we also did not see any runoff in this situation. And we did have water that infiltrated into this container. The goal here, again, is like we talked about earlier, is we want to see infiltration occur on 100% of our soil surface. All right, let's see what this one looks like. So our surface is pretty smooth. What does it look like underneath? It's bone dry. So again, That was about an 1.5 inch rainfall event in like 30 seconds, right? I mean, that was an extreme situation. And for the purposes of this demonstration, I really like to be able to show that. But we live in a world where, we talk about, 4, 5, 6 inch rainfall events in 12 to 24 hours. I mean, these are really extreme situations, and our soils need to be able to be resilient enough to handle those types of events. So again, on this situation here, this soil with high disturbance tillage system, we didn't have any infiltration. That bottom of that entire soil is wet. And we had nothing that went into that bottom container, our infiltration container. So let's think about that, and let's take that to the next level here, because that might be just one rainfall event that we talked about today. Well, what happens if it rains again tomorrow or the next day? Is this soil going to be able to infiltrate anymore if it couldn't even infiltrate the first amount of rain that I put on it? And will this soil be able to continue to infiltrate water in these situations when we have higher organic matter, more pore spaces, different things like that? We see that this soil will be more resilient and able to infiltrate more water. But let's even take that a little bit further out and think about effective rainfall. So throughout the growing season, we know we all talk about and keep track of the amount of rain that we get, right? I got an inch of rain. I got an inch of rain here this week, or we like to see an inch of rain every week for a good corn growth. But if all of it runs off every time it rains, how much rain did you really get? How much rain did you really keep? And that's really what we want to think about when we talk about building soil function and healthy functioning soils, is that we want it all starts with having those living plants and photosynthesis occurring. And then it also is keeping that rainfall on that landscape, so that rainfall, it's effective rainfall. It's rainfall that you keep in your soil for your plants to grow. Because we know that although it's raining today in Indiana, come July or August, when we need rain, is that soil going to have that water in its profile to give back to the plant? And so those are really, really key aspects of soil health that we want to focus on with our gardens and where we grow food and how we manage that landscape. Because when we see that function come back, we see things start to thrive where we can water those gardens less or water that landscape less. We might see with diverse crop rotations, we might see greater disease resilience and other things like that in these systems. And so again, the basic idea of soil health is that we want to focus on function and bringing that function back to our landscape. So that's all I have for demonstrations here today. Is there any questions or thoughts that anybody has? Is there any discussion that we want to kind of bring forward and talk about? Like Bree said at the beginning of the event today, this is just the baseline, right, or the foundation, because next week Allie's going to go into intensively into conservation practices on your landscape that you can use that kind of promote those soil health principles and help do all the things that we talked about today and regain soil function. And then, going into the beneficial insects and the things that we will start to see out in our gardens as we build soil health and as that system thrives. And then lastly, again, cover crops as a tool that you can use to do some of these things. So, that's about all I got for you today. But I just wanted to just kind of let you know that that's how we built this session, was to kind of start with this and then go from there as we continue on. So.
Thanks so much, Stephanie. There was one question. I don't think we got to this one. If our soil would be like the soil on the right, would that have an effect on the need for irrigation? Did you cover that one?
Our healthy soil? Yeah, absolutely. So as we find, as we build that healthy functioning soil, some of the things that start to happen is we start to see organic matter accumulate, and organic matter, having greater organic matter in our soil helps hold more water. And so we would essentially need to irrigate less, or you could find yourself you could irrigate more efficiently. So yes, it would impact irrigation. The other thing is when we have good soil cover, we see less evaporation. And so that's the thing that happens a lot with irrigation, is that water hits the ground, and then it's the burning hot sun, and that water just evaporates right off that soil again. So if that soil surface is protected, it can keep that moisture in the soil better.
Well, we have no new questions in the chat, just a lot of exclamation points about how exciting these demos are. So thank you so much, Stephanie, for sharing those today.
Thank you
Actually,
for inviting
Bree,
me out, Bree.
I'm sorry, Anne had a question. I think that was sent to me. And she's asking about, there may be some runoff, but what cost are you talking about for putting cover crops on about 2,500 acres? And I know that's a quite complicated formula. What would be your advice to her if she's looking at costs associated with that? Where to start?
So if she's actually looking at like trying to get an estimate of what cover crops would cost, I would, highly suggest that Anne maybe work with a seed vendor or her local conservation district to see like what types of costs there would be with putting a cover crop out there. Depending on if you're using, say, a cereal rye mix or oats and radishes, those costs can be relatively low, or they can get higher, depending on kind of what you're putting out there in those mixes. I will say that increasing diversity in your cover crop mix does not necessarily increase your cost, but it does depend, that cost is dependent on the species that you put in that cover crop mix. And so just being aware of those types of things. So yeah, there is a cost with that investment, but sometimes if you can look at that and find things that you maybe can take out as you're adding cover crops. So if you work in a system or you have fields or gardens where you're putting cover crops in, you're for surely not doing fall tillage anymore. And in row crop systems, that can be quite costly, to go across those fields every fall with large tractors and deep rippers and other things like that. And so those costs can be subtracted off. So maybe those things can start to balance each other. But Anne, you're right, especially up front as you start to put this investment in there. It is about calculating that investment cost while you look for those benefits on your landscape and reap those benefits off the landscape as well.
We have a couple more questions and comments. I will say in kind of response to that as well, a good point brought up in the chat was there are Farm Bill programs that can provide assistance, especially if you're trying those out. So don't forget those, and thank you, Jan, for highlighting that. Dan had the question, does the amount of precipitation factor into the percent of the soil organic matter?
I guess yes and no. That gets to maybe to be kind of a sciencey question, but the more precipitation that we have in our landscapes, the more that we see organic matter cycling and those types of things actually occurring. And we can so try to think about how to answer this. There's a lot of different aspects to this to think about. But so let's say Indiana or Connecticut compared to Arizona or other parts of the Western United States. We get a lot more rainfall here. And what we tend to have is that our organic matter and our residues will break down more easily, and we see better nutrient cycling, and we'll see organic matter accumulate because of that. Whereas if you head out further west where it's a lot drier, they may have that grass prairie systems, but those residues, they aren't rained to the ground and they don't decompose in the same way. So it takes a lot longer for that organic matter to break down and get into the system. And also because of all that sun and heat, they also lose organic matter a lot more easily. Also, if we take that and we go say to like where I grew up in Minnesota in comparison to say Indiana or further south, when you have a lot of your moisture is in snow or you have frozen ground, it takes longer to accumulate organic matter, but it also takes longer for organic matter to break down. So and then if you go and you look at Hawaii, where it rains, how often, and the temperatures are consistent, they cycle organic matter like crazy. And if you're not constantly having plants growing in those systems, those soils burn themselves out because they don't have that organic matter, and they start to become degraded very quickly. So moisture is a critical element. It's really key for organisms and nutrient cycling.
Okay, and we have one more question, and I definitely want to get to it, although we are right at time. But Gwen did want to know if you were aware of what the cover crops were in the demo sample.
There was some brassicas, so like a kale and a radish. There might have been some sun hemp and sunflowers, some sorghum sudan grass. So it was a pretty diverse warm season annual mix is what it was. Sorghum sudan grass, sun hemp, sunflowers, probably some different clovers, probably beer seam clover, crimson clover, and some different brassicas and things like that. So yeah, it was a pretty diverse mix, and there was a lot of flowers out there and a lot of different bees and soldier beetles and things like that when we were out in that field collecting that sample in the late summer. So I've had that sample for quite a while, and it still continues to perform very well.